Welcome to our Math 154 videos. We are going to be focusing on trigonometric derivatives in this video, and you'll see we have this equation here, f of theta is equal to sine of theta times tangent of theta. And so in order to take the derivative, we need to know the derivative of sine of theta, and we need to know the derivative of tangent of theta. And so if you learned your trig derivatives, you'll know that the derivative of sine of theta is cosine of theta, and the derivative of tangent of theta is secant squared of theta. Alright, now we have our function sine of theta times tangent of theta, so that should tell you that to take the derivative, we need to use the product rule. So we're going to go ahead and do that. Product rule says we take the first function, sine of theta, and we multiply it by the derivative of the second, which was secant squared theta, because that's the derivative of tangent of theta. Then we're going to add to it our second function, which is tangent of theta, and multiply that by our derivative of the first function, which is a cosine of theta. Now you'll notice here, this tangent of theta is really sine of theta over cosine of theta. So we get these two cosines canceling out, and we're left with our sine of theta times our secant squared of theta plus just a sine of theta, because our cosines canceled out. Now we can go ahead and factor out this sine of theta, and that's going to give us a secant squared theta plus 1. And we'll go ahead and leave the derivative in this form, and there it is. So you'll notice that if you remembered your product rule and know your trig derivatives, then this derivative becomes pretty straightforward. So here's a second example, and it's very similar to the first one. We have two trig functions being multiplied together, but now we're going to need to get the derivative of cosecant of theta and the derivative of cotangent of theta. Now, I like to remember that any derivative that starts with a c is going to be negative. So these are both going to be negative something. And if you remember, the derivative of cosecant of theta is negative cosecant of theta cotangent of theta. And the derivative of cotangent of theta is negative cosecant squared theta. Alright, so now we can go ahead and apply our product rule. So we get g prime of theta is equal to, so we take our first function, cosecant of theta, and we're going to multiply that by the derivative of the second one. So the derivative of cotangent of theta is negative cosecant squared of theta. Then we're going to add to it our second function, cotangent of theta, and then we're going to multiply that by the derivative of cosecant of theta, which is negative cosecant of theta cotangent of theta. And now we're just going to do this multiplication here. So we'll get our first term here is a negative cosecant cubed of theta, because we have one cosecant here, cosecant. It's really like a 1 for an exponent in there, but we don't have to write it. And then there's a 2, so add them. That's 3. Then we have cotangent of theta, and let's see, there's 2 of those. So we get cotangent squared of theta, and that's going to be multiplied by our cosecant of theta, which is negative, so really this plus out in front we can change to a minus. And we'll notice that both of these terms have a negative cosecant of theta. So we can go ahead and pull that out. So I'm pulling out a negative cosecant of theta. So the first one, we're left with 2 more cosecant of theta. So we get cosecant squared of theta. And then we're going to add to it, because we're pulling out this negative, whatever was left, which is going to be a cotangent squared of theta. Alright, and that is going to be our final derivative. So here's our last example, and this one's a little bit more complicated. So we still have our trig functions, cosine of x and sine of x, but now we have a quotient, and you'll notice the numerator is also a product, x times cosine of x. So remember, the derivative of cosine of x is negative sine of x, and that's because anyone that starts with a c is going to have a negative derivative, so that's an easy way to remember. And then we have the derivative of sine of x is cosine of x. So we're going to use those two combined with the product rule and the quotient rule to find y prime. So we're going to go ahead and start out with our big giant quotient rule. So that says we need to take the bottom times the derivative of the top. So that's low d high, if you like to think about it that way. So our low function is 3 plus sine of x. And our d high is where we have the product rule. So we're going to take x times the derivative of cosine of x. So we're going to get a negative x sine of x, because the derivative of cosine is negative sine. That's why there's that negative out in front there. And then we're going to add to it cosine of x times the derivative of x, which is just 1, so we have just cosine of x. And that finishes our low d high. Now we're going to subtract our high d low. So our high function is x cosine of x, and our d low, well, the derivative of 3 is just 0. And then we add to that the derivative of sine of x, which is cosine of x, and that's multiplied our high d low, so we're going to multiply that by our cosine of x, because cosine of x is just the derivative of the bottom, because we have a 0 for the derivative of 3. And then our quotient rule says all of that has to be over low squared, so that's our bottom, 3 plus sine of x, and we're going to square that. Alright, so now we have a lot of simplification to do. So first we're going to distribute this 3 out to both terms, so we'll get a minus 3x sine of x, and then plus a 3 cosine of x. Now we're going to distribute the sine of x to both terms, right? So we'll get minus, that's going to be an x sine squared of x, because we have sine of x times sine of x, that's sine squared of x. Then we're going to multiply the sine of x by the cosine of x. So we're going to add to that a sine of x, cosine of x. And then we still have over here this term, which is going to be minus an x cosine squared of x. Now you notice we have an x sine squared of x and an x cosine squared of x. So right after we put all of this stuff over our 3 plus sine of x squared, we're going to use the fact that we have a minus x sine squared of x minus x cosine squared of x, and we're going to factor that minus x out. So we're going to write everything else down first. 3x sine of x plus 3 cosine of x. Then I'm going to skip that sine squared of x term, and we're going to write plus sine of x cosine of x. Now these two terms here, what are we going to do with those? Well, we're going to factor out our negative x. Then we have a sine squared of x plus cosine squared of x, which conveniently is 1. That whole thing is still over our 3 plus sine of x squared. We don't really want to do anything with that denominator, because that would make it kind of ugly. So now what do we have? We have a negative 3x sine of x plus 3 cosine of x. plus sine of x cosine of x, and then just a minus x because the rest of that was 1. And then the whole thing over our 3 plus sine of x, quantity squared, and that is pretty much as good as we're going to get. So we're going to leave that, and there's your derivative.